We're now going to talk about part 2 of our coverage of single-stage completion methods. In this part of the lesson, we're going to talk first about the thenAccept completion stage method, and then we're going to compare thenApply and thenCompose. So the thenAccept method is also a completion stage method that's triggered by the completion of a single previous stage, like thenApply and thenCompose. Except this is a bit different. First, it takes a consumer action rather than a function. And what that means is that there's really no return value. A consumer just consumes or accepts a result, doesn't have an output. And this, therefore, behaves as a callback. You can think of the action you pass in here as a callback. Hopefully, you're familiar with what a callback is. And it's typically used when you want to have a side effect. You don't want to return a value, you want to have a side effect. And in fact, thenAccept does not return a value per se. It simply returns a completable future indicating something's done, but the return value, in quotes, is void. And if you want to learn more about the Java void type, take a look at this article down here. It's kind of a funky type that's used to hold the type system together when you have various types of generics that require parameterization, but you don't want to return a value, as in the case here. We typically limit the use of thenAccept to the end of a chain of completion stages. So you can see here that this is the same example from before. We went ahead and used the supply async method to reduce a big fraction. We then used thenApply to get ourselves a mixed string for that. And then finally, we use thenAccept, which is going to have the side effect of printing the result out. So when thenApply, when the completable future returned by thenApply completes, thenAccept is called, and it will go ahead and have the side effect of printing that to the standard output. OK, so the downside with, so you should really limit yourself to using thenAccept at the end of a chain of calls, like this one, the last item. And the reason for that is if you don't do that, you can end up with callback hell, where you have all these nested callbacks. And this is something that's very typical in JavaScript. If you don't use it properly, you end up with these deeply nested callback chains of asynchrony, and it's just a big mess. So read more about callback hell in the link here. So those are the three primary methods: thenApply, thenCompose, and thenAccept. Since thenApply and thenCompose look very similar, let's explicitly compare and contrast them. So at one level, thenApply and thenCompose look almost identical because they appear to have very similar method signatures. You can see that they basically take functions. Both of them take functions, and that can be confusing at first glance. Unlike thenApply, however, thenCompose can be used to avoid unwieldy nesting of futures. And here's an example to illustrate this point. So if you use thenApply instead of thenCompose, if you go back and look at the previous part of the lesson, we had thenCompose here. If we put thenApply here instead of thenCompose, and we call a method here that does asynchronous long-duration computation that returns a completable future, we'll end up with nested completable futures. So you'd end up with a completable future to a completable future to a big fraction, which, for my money, is very ugly and verbose and hard to get your head around. So therefore, if you use thenCompose, it denests or flattens the results, so you end up with a completable future to a big fraction instead of a completable future to a completable future to a big fraction. So knowing this is very important, and it'll turn out to help you with the programming assignment, because when you use thenCompose properly, you don't end up with nested completable futures. Now, there's some other methods that are also important to know, and you'll need to know them for your programming assignment as well. The thenApply async method can often be used to replace nesting of thenCompose with supply async. So if you feel yourself tempted to use supply async inside of thenCompose, you might be better off, in fact, you probably are better off, using thenApply async. There's an async version of thenApply, which will run the computation in its own thread, its own worker thread on the common fork join pool, thereby eliminating the need to have this completable future supply async with some action style. So thenApply async is a really nice way of having things run asynchronously, but not having to worry about nesting, because we don't have a completable future generated here. We just have some computation that runs asynchronously, and thenApply async returns a completable future to the result of that action that runs in the background thread. So I like thenApply async quite a bit. You can also use thenCompose for other purposes, to avoid calling join when you need to flatten nested completable futures. And this is a little bit more of an esoteric use case, but it's worth knowing about. So here's an example where we have a call to supply async, and the method we call as the action, as the lambda action in supply async, itself returns a completable future, which does occasionally happen. So if that happens, if you have that, then you've got, once again, this completable future to completable future issue. And one way to get around this is to use thenCompose with function identity to flatten out the return value so there's just one completable future. And I forget when I stumbled upon this clever trick, but it is pretty cool, and there are situations where it helps you out to avoid having to have completable futures to completable futures. So function identity, just again, it can be used to help denest or flatten these results. Perhaps an even more effective way to do it, instead of doing this, is to, well, I'd like to take it back. That's one solution. If what you're composing also returns a completable future, then you can use thenCompose async. Very much the way that we used thenApply async to avoid nesting, we can use thenCompose async. So what that will do is, even though this longer blocker returns completable future method, called by this method reference, returns a completable future, thenCompose async will run that in the background and ensure to denest it. So it's important to understand these other variants of the single-stage completion methods for two reasons. Number one, it's cool to know how they work. And number two, you'll have to use some of these in your programming assignment to avoid unnecessary nesting. So that's the end of the second part of our coverage of single-stage completion methods. And you'll see that all those things are very important to be aware of to do the assignment correctly.